So I'm going to provide you a use case that recently I worked on, wherein there was a requirement of a customer that they wanted to have a database synchronization between the two Oracle DBs. So this is the agenda. I will explain you, I will give you an overview about the use case, what use case is all about, then what solution did we propose. And then I will go a little bit technical on how does the Oracle CDC connector works, what are the different challenges that we faced in implementing the use case, and what solution did we approach, and towards the end, what lessons did we learn. So let's start with the use case overview. So the requirement was, as I mentioned, there are two Oracle database. One is in zone 1 and one is in another zone 2. So they wanted to replicate or have a near real-time synchronization between the source and the destination Oracle DB. There were different tables. Each of the tables had primitive data and as well as LOB columns. So LOB columns specifically, they were focusing on the NCLOB. So I will come and explain details in the forthcoming slides. So this is the overall use case. They also wanted to implement a bit of a transformation in between, but which is again, it's a future scope, but not at this currently. It has been designed. And then the end applications, which is like consumer application 1, 2, or different application, which they wanted to connect with the destination Oracle DB. So what solution did we propose? So the customer already had a Confluent platform on-prem installation already installed. So we proposed we can use a source connector and we can use a sync connector to source the data from the Oracle DB from the source side, publish it to the Kafka broker, and from the Kafka broker, we can sync it to the Oracle destination DB. Now, we are also using schema registry for the serialization and deserialization. Along with that, we are also proposed to use a KSQL DB cluster for the message transformation. Now, this is just a technology stack. As I mentioned, database, we had two databases, Oracle DB, Oracle 19C. And for the event streaming platform, we use the Kafka broker, Kafka Connect, schema registry, and KSQL. For the source connector, we propose to use Oracle CDC Source Connector. And for the Sink Connector, we propose to use the JDBC Sink Connector. Why did we propose the Oracle CDC Source Connector? Because this is, since the customer already had a Confluent license, and this is also this connector also requires a license. So that was the reason that we proposed that it's better to use the Confluence CDC Source Connector. No, so I'll just give you a brief of how does this Oracle CDC Source Connector works. So if you see on the left side, right, we have the Oracle DB. So how does what initially the Source Connector does is, it establishes a connection with the Oracle DB, okay, and then it reads the redo log via the vlog miner content. Now, once this raw data is being read by the connector, it publishes into the redo log topic. Okay, this is a basic design. All the raw events from all the tables, everything is being published into the redo log topic. After that, once the data is published into the redo log topic, the connector reads these content from the redo log topic and then publishes into a different topic specific to the each of the table. So as you can see on the top, we have the db.schema.table1, db.schema.table2, like that, right? So each of the topic is specific to a different tables. Now, since we also had an LOB columns here, there is a provision to configure a separate topic for the LOB data. So hence, what connector does is, based on the configuration, it will create a separate topic for the LOB data. So if you see on the below, right, table 1 hyphen column.lob, I'm referring to the below one. So it's like that, a different topics are created for the LOB column. Please note that the boxes of the blue boxes are all part of the Kafka broker. It is not a separate component since topic resides in the Kafka broker. So that's how the data flows from this Oracle DB to the topic. So here you can see below, I have given an example of how the data topics are created. So for example, if you have a table called oracle.admin.users, this is for the primitive data. Primitive data is a regular column. the same name can be used, created. So both of this, be it a regular primitive data or the LOB data, you can configure the name of the topic. It's completely up to user. There's no default. But if you use the default, like how I have used here, like fully qualified table name, the connector will create a topic accordingly as per the schema of the table. So that's how the Kafka topic is created. So this on the left side, if you see, this is the primitive data. On the right hand side, if you see, I have configured the LOB topic name, like, with the parameter called lob.topic.name.template, which is table name hyphen the name of the column and hyphen. I have added a string called LOB just to identify that this topic belongs to the LOB topic. So if you see that Kafka topic is again created like admin is the name of the table, notes is the name of the column, and appended with the LOB. So this is how your Kafka Connect worker works. So now the challenges. So when we configured this data, without anything, we observed that what was happening is the specific, the primitive columns of data were coming as it is, and there was no difference, or we saw observe the data is coming as it is in the Kafka topic. However, specifically for the LOB column, since the customer had configured the LOB column as an NCLOB, the data was getting converted into byte format. So that's where the challenge happened. So we were like wondering as to why the data is coming in a byte format rather than coming as a plain text or string. So why those challenges? I'll just explain you here. So before going to that, I'll just give you a brief overview about what is LOB. LOB is a large object. It's basically a data type defined by Oracle to store a very large data volumes or the values basically. Why it is used for? It can be used for storing a data like document, images, video, large text, or XML file. Okay. So there are three types of LOB. We have blob, which stands for binary large objects used for storing the images, PDF, video, or any binary file. The next one is CLOB, which stands for character large object. Basically, if you have a very large text or you have a big JSON file, JSON content or XML content, that is for that. The next one is NCLOB, which is a Unicode character set. For example, if you have a special characters, if some of the strings may contain a language specific characters, your native language or something like that. Or if you have a smiley character or some characters are special characters wherein if you see that you have a character on top of it, you have a two dots, or O is with a line. So those are the characters that is part of the NCLOB. So here I will explain you how is the data actually gets stored in the database. Now, if you see, I have created a sample table here in a table name with an employee, which is having ID as a number, name as varchar, and the notes as NCLOB. Now, primitive columns are stored as it is, whatever is being passed as on. So for example, I have a name called 101 and then the name is John. It is stored as it is. Okay, I think there's a small mistake. So that's how the data gets blocked. But in case of LOB doesn't get stored as it is. In place of LOB, there is an LOB locator or like a pointer where the actual data is present. So the row will contain only the pointer, but not the actual data. The LOB column is stored in a separate place. It's stored in a separate segment, and it is split into different chunks because an LOB column data can go up to 4 GB and storing a 4 GB is practically not possible. It's not viable solution. Hence, what Oracle does is it splits into multiple chunks. The size of the chunk can vary from 8 KB to 32 KB, depends upon what you configure it. So that's how you will see the data. This is the actual data. So for example, this is a this is the sample data that I have provided. So this is a data for the NCLOB containing large text, something I have written given the text, right? This is split into different chunks. So that's how your data gets stored, and that is the difference between storing a primitive data and a LOB data. Now, so this is just brief, like whatever I have explained, right? But internally, specific to the LOB data, what happens is the Oracle converts that all the chunks into byte format. It doesn't store as it is, it gets converted into binary or byte format. So this is where your challenges comes in. So when we were reading it through the CDC source connector, we observed that the data, LOB data was coming in the byte format. And this is the main reason because Oracle stores it into a raw binary format. Now, another important point that need to be considered here is the character encoding. Each of the three different types of LOB have a separate a character encoding. Blob, actually there's no encoding. It gets stored as it is. CLOB, it gets stored into as UTF-8, which is exactly not same as it, but Oracle has defined its own character encoding, which is AL32 UTF-8. For NCLOB, it is actually stored into UTF-16 character encoding. And this is where we had a problem. I will also show you why this problem is appearing from the Kafka side when you try to source it. So when this is just the same thing which I explained. Okay. So what happens when just a minute. Yeah. Okay. So what happens probably I'll just explain you. I'll come back to the slide later. So what happens when the data gets sourced from the Oracle DB by the CDC source connector and publishes into the Kafka topic. It depends upon whether you're using a JSON converter or a Avro converter. When you're using a JSON converter, the raw binary data specific to the NCLOB I'm referring to here, it takes the raw binary data, it encodes into a base 64 string, wraps up into a UTF based JSON message, and then publishes into the Kafka topic. So you see a difference here. The UTF-16 raw byte data, it's get wrapped inside an UTF JSON message. By default, Kafka uses UTF-8 encoding. So that is the reason the Kafka topic, you have an UTF-8 data. Now, when we were reading the data directly, this is the reason we did not see a raw data of the NCLOB column, which was present in the source DB. We were seeing a base 64 encoded message. If you use an Avro converter, something similar happens. The Avro converter uses the data process binary data as it is. It wraps inside an Avro binary message and then publishes into the Kafka topic. So in case of Avro, what we were seeing a lot of binary strings like /u000 like that. We were seeing a lot of binary messages. So in either case, the string that was present in the source DB is not directly visible in the Kafka topic. So this is where our challenge came into pictures. How do we recreate the actual message so that the data can be sourced from the Kafka topic and published into the destination Oracle DB. So this is the solution that we approach. So for the primitive data, we do not have to do any conversion. The data can be read as it is because there is no conversion, there is no wrap-up message, anything, because it is simple plain UTF message as it is. So we use the JDBC Sink Connector. The insert mode that we configured is absurd because any changes that happens in the redo log, be it an insert, update, or delete, that will be taken care by this specific mode. And the primitive data gets published into the or pushed into the destination Oracle DB. In case of LOB, we had to make some small changes. We had to use custom SMT. So what that SMT or single message transform did is, it reads the raw bytes from the Kafka topic, decodes the UTF-16 message or unwraps the UTF message first, decodes the UTF-16 message into a string. If there are any null characters present, this is an additional check that we did, and then presents the clean string that was present in the source as it is to the JDBC Sink Connector, which eventually publishes into the Oracle 90C, which is the destination DB. So this is how the entire solution works. So I'll just pause here for a moment. Any questions so far for anything or any of the previous slide deck you have? Yeah. So
the bigger data is stored in a chunk, one chunk, multiple chunks, correct?
Yes.
So how are you going to assume if the data is maybe 100 MB or 200 MB, how you are going to pass that to the Kafka topic? The whole source is bigger data size, right? So is the Kafka supporting that big size, or how are you gonna make that consistent chunk? You have to somewhere you have to
Right.
them into the DB, right?
Right. So that's where your CDC connector does the job. It rebuilds the entire message as it is and then publishes into the Kafka topic. We do not have to, as I say, Kafka does not do that. The data is been reconstructed and then gets published into the Kafka topic. CDC takes care of it.
So, but Kafka supports that huge size of transmitting.
No, there is a limit there. No, we cannot process more than 1 MB of message size, because otherwise you will have a performance impact. So we did recommend this solution that, if you want to do it, you will have to either reduce the LOB column size from your destination. Otherwise, we will have to split it into multiple Kafka topic. But yes, yeah. So in the CDC, sorry, we don't need to separately handle it, but I think there is a parameter available in the CDC connector where you can say what is the maximum size that you want to process it. That is possible.
But in the source side, you have to again wait for those chunks to arrive, right? The Kafka topic listener side, you have to wait for that chunks to come in, and then only you can put it into the one record.
Yes, but see, if you look into the log miner, right? So log miner will inform, or I mean, see, since the CDC connector is talking to the log miner internally, since when it establishes the connection with the Oracle DB, right? So log miner is the one which is providing the data. So once after the log miner process all the LOB data into small chunks, it informs the connector. So that's how it goes. It is not like, even though it is a continuous processing, but in specific to the LOB columns, once the entire data or entire LOB data is split into smaller chunks processed, that's when gets informed to the CDC connector.
Okay. Okay. Thank you. Yeah.
Log miner is an inbuilt utility with the Oracle DB. So we don't need to have neither the CDC connector has it. It just talks to the log miner.
So mainly only we need to take care of this part.
Yes.
Where this connector.
So this part is specifically for the NCLOB because it is in the UTF-16 format, right? So if you check, as I mentioned in one of the previous slides, I'll show you. Here, right, the character set NCLOB is by default defined in AL16 UTF-16. So since it is programmed in Java, right, and Java uses default UTF-8, so this is where the challenge comes. If you have a CLOB, you don't need to do any of this processing, because CLOB is by default UTF-8. So without SMT, you can directly process it. So there was another solution that we thought of using, casting the bytes to string, but then there were challenges in that. What was happening is, since UTF-16 is a 2-byte representation, right? So Little Indian, 1 byte is, I forgot that.
Little Indian, Big Indian.
Yeah, Little Indian, Big Indian. So 1 byte was not getting converted and it was default assumed as a space. So each of the data was coming like one character space on one character. So to solve that problem, we had to use one more SMT. So this was eventually, we had a 2-stage of SMT. So to avoid that problem, why to have 2-stage, which we can do it in one single step. So that's when we used this solution. So this is not only quicker in one single step or single stage of SMT, we can achieve the NCLOB or rebuild the NCLOB string as
so somewhere I saw that KSQL.
Yeah, that was for the transformation. So
transformation. This is only different.
This is only the connector, like Source Sink Connector. So KSQL transformation was a future work that we are still working on right now, because they wanted to build a report. I mean, they wanted to have an internal report for all the tables, right? So they want to do some merging and then transformation. Okay. So that's where your KSQL DB will come into picture. But this entire pipeline from the source to sink, KSQL transformation is not coming. This is only specific to the NCLOB. How did we handle the NCLOB?
Okay.
You used to insert mode as upsert, right? Is it because we are chunking, or any what is the reason?
I'm sorry, I didn't.
Insert mode is equal to upsert.
I'm sorry, I'm not able.
There is an insert.mode is equal to upsert, right? Above the box. Insert.mode is upsert.
Yeah.
Is it because we're chunking, or what is the reason?
So the reason that we use upsert is since the primitive column data is handled separately and the LOB column handled separately, even though they belong to the same table, we don't know how the data is arriving at what order, right? So in case if the LOB column arrives first, So what the JDBC Sink Connector will do is it will create the row as it is with the primary key and the LOB, and later on when this with this for the same row for the same primary key, if the primitive data comes in, that will get inserted. So that was the reason we use this upsert mode, because we don't know how the order is there. Since LOB and primitive belong to are in a separate topic, so this is another challenge. So that was the reason we use the upsert mode.
So my question is on the blob basics, three types, C blob, B blob. So suppose my column type is B blob, but I try to insert some you told files, right? PDF falls into this. If I try to insert, will the insert query fail there or it will go?
So you're saying you
So
have
out of the
defined a
three-
column as
yeah.
blob and you're inserting a PDF file.
Yeah.
Yeah, so Oracle will still accept it. And
Will-
here we don't need to use any SMT transformation, because anyway it is still going to be a raw binary format, right? So there is no transformation need. So we can use it as it is. So JDBC will understand that this is a binary format and publishes into the the destination Oracle DB.
So suppose some developer is unsure about the type of data falls under which category, C blob, NC blob, or this blob. What is the safest or most performance efficient column type he should choose, irrespective of the data, because Oracle will take care of data transformation.
No, I think you should not choose what is the type of LOB column you should choose, because it depends upon the content that you are putting into the column. So I'll show you the previous one.
Yeah. Yes.
Yeah, if you see here, right, say for example, if you have a very large text, you would not want to define it as a blob, binary lob, because it is not a binary, it is a string. So in that case, you use a C lob. So depends upon what your data is for that column, right? You have to define that. So if you don't know how is the column type defined for the LOB, I would suggest you run a SQL. There's a command to check what is your column type.
Okay.
So you can go to the Oracle DB, check the column type, and then take your necessary action accordingly.
Okay, sir.
Hi, Balaji.
Yeah,
Girish
hi.
from Smarsh.
Yeah.
So, couple of questions I have. Probably I'll go one by one.
Sure.
So, if I go to your first one, so there are two zones, right? So, I assume these two zones are geographically apart, or they're in the same geography. It's just that I need to sync between.
Yes, you are right. They are in different geographical zones.
Geography. Okay. So, there could be some latency, right? So in synchronizing, because zone 1 data keeps coming in, that you need to sync with zone 2, because zone 2 is where all the applications, users are connected or whatever. That's primary, the live database where business is running out, right? So there could be some delay between geographies, right? So have you set any expectation that the moment the content comes here, you will see the content in 1 hour or whatever? If you have projected, what is the basis on which you have derived that value?
So that's a very good question. So initially, when we ran our test, we did not measure the performance of the latency. We were just wanted to observe that whether the data is getting synced in a real time. So we also observe some data coming like maybe after 10 seconds or 20 seconds, specifically for the LOB columns, right? But for the primitive data, this was almost near real time. So we did not get into that stage yet. The performance still has to be, it still needs to be performed. But that's a good point. But I do not see, I mean, when we initially tested from the initial network latency test, we did not see a big difference. We saw that it is almost near real time. But actually, when we run the test with this actual sample data which the customers are using, maybe that time we will come to know.
Okay.
But yeah, definitely, if it requires, we may have to do some performance tuning from both connector side and as well as the broker side.
Okay, thank you. The second question is, there are some integrity checks, right? So on the source database. So and this sync is async, means the packets could come or the topics could come out of order. So have you ever faced a challenge where you fail the integrity checks on the inserts or updates here?
To be honest, no, we did not encounter that problem. When we ran with the sample data, we were running it in continuous loop. But it was more or less the same set of data that we were running. So we did not face that kind of problem.
Okay, perfect. So one last question. So this logs, you explained it, there are multiple chunks stored on the source. You should also ensure on the destination, so they are equally stitched in the same order, right? So on the source, the log is a 3 GB, say for example, and it stores in the chunks. Source could store in chunks at different places.
Yes.
So when you're reading, they could come out of order. But on the destination side, they should go and sit in the same order, so that when somebody reads on the destination, the whole lob should come as a good packet than out of order packet. So again, anything extra care you're taking to ensure that lobs are also inserted in the right channel, or database itself takes care, irrespective of which order I insert into the database.
So we did not very validate from the chunks perspective is whether the chunks are coming, because it is a very low level validation that we do. So
Okay.
I mean, it requires we have to go really low level. So we did not get into that stage.
Okay.
So what eventually we did is, once the database, when the data is available in the Kafka broker, we validate it in the Kafka topic, Kafka Avro console consumer command, you run and you see whether data is coming or not for the both primitive and as well as LOB. Since you raised this question for the LOB, right? We were observing that it was coming in a binary, as I mentioned, the 2-byte binary, little Indian, big Indian, right? We were observed that was coming. So once that is coming, we were assuming that the JDBC Sink Connector will also construct the data as it is and publishes it to the destination Oracle DB.
Okay.
So we went and opened the destination Oracle DB, selected the specific column, with the ID, whether whatever we are pushing it from the source side, is it coming in the same way or not? So we verified that it was coming in the same order, character by character. We measured it.
Okay.
So that's how we did a validation.
Okay.
So verifying the chunks is very difficult, I'm sure, because if anywhere things are breaking, it is either breaking by the log miner or the JDBC Sink Connector.
Okay.
So whatever the data that is presented by the log miner to the source connector, the same data will be available in the Kafka topic. So JDBC connector does not know what data it is. All it knows is I have some binary data which I have to publish it to the destination.
Okay. Thanks, Bill.
Yeah.
Any scaling parameters you have tuned to make sure that, say, that JDBC connector can handle the large volumes of LOBs that you get?
So scaling perspective. So for each of the table, we had a separate, JDBC Sink Connector, and within for the same table also, one connector for the primitive and one connector for the LOB column. So for example, if the table had 7 LOB columns, right? So we had 1 for primitive and 7 for the LOB JDBC
so
connector.
each LOB
Yes.
column is handled by one connector at some
Yes.
point.
So in that way, we did an initial performance testing also. We did not see a very big change. We observed that, we were observing the CPU resolver.
If you have one for each one of it, yeah, I could imagine.
Yeah. Initially, we wanted to club, all the primitives, because primitive can be handled, have one, since we had some multiple tables, right? For all the primitive columns, we wanted to do that, but we felt if anything breaks, why should the other tables be impacted? So that is the reason we created a separate connector for each of the primitive columns for separate table and LOB columns separate JDBC Sink Connector.
And when JDBC connector inserts or updates into the destination, it's an atomic operation, right?
Yes.
So they both, your non-LOB column data and then LOB data comes as one atomic operation and then inserts into. So it's mostly running a single thread process that manages one message. Probably that Kafka connector which connects to that source and destination is single threaded process, right?
Yes. So any change that happens on the source DB, right? So for example, it's a update or insert or delete, everything is captured as a Kafka event in the topic. So that's how the data gets processed, and eventually the same action is taken care by the JDBC and does it over the destination DB, be it an insert, update, or delete. So delete is a separate thing, because JDBC, the Oracle source DB, right? If a delete operation happens, it tells the Kafka. So if you see the message, there's a parameter called op_type and :D. If you just decode the message of the and the Kafka topic side, but JDBC doesn't understand that this is a delete operation. So in such case, you will have to use another SMT, which converts the entire row content as a null, so that it becomes a dead letter. A tombstone record. So eventually JDBC Sink Connector deletes that record. So you will have to use another SMT over there. It is not a direct one.
Okay, thanks. That helps.
Sure. So by default, the Confluent platform was, configured with MTLS encryption. Okay, so by default, the Confluent platform, when the installation was done, it was done with the MTLS encryption. So all the data that was moving between the source and the destination, it was all encrypted. So we did not do anything specific for that. Yes, that's a very good question. So they specifically wanted, since if you see the previous the design, right, or if it was a direct transformation, between the source and the destination, yes, you can use the native Oracle tools. But here, in case they wanted to do a transformation, right, and that transformation was possible using the KSQL, and KSQL is part of the Confluent. So that is the reason we use this solution. It's not about only the near real time synchronization, but we also wanted to have a transformation. So as I mentioned, they wanted to create a reports from all of the tables. I know they have, this is a telecom company. So they wanted to have a customer's report, transactions, when the refund happened. There are different things, there are different different inputs that they were looking into it. So that was the reason we said this would be a better solution to go with the Confluent platform. And not use the native Oracle tools for data synchronization. Okay, so I will move on to the last slide. So as I said, what we learned what we learned from this is, whenever you have a LOB columns that needs to be studied properly, you understand how the message is published in the Kafka topic. Are you getting it in the same way or not? And then analyze it and take also consider the character encoding, which is very important, because if it's an NCLOB, it is going to be UTF-16, but if it's a CLOB, UTF-8, you don't need to do anything. So that was the reason we felt, whenever you are building any use case that involves an NCLOB, please make sure that you understand how the data flow is happening and take your corrective action. You may have to use SMT if it is needed in your use case. So yeah, that's pretty much I have for the today's presentation. So thank you everyone. If any questions, please let me know. Any other questions?